And we're back. We won that game. A very exciting game if we didn't get to go to it. Also, going to have a special shout out to Mitchell, Pippa, and Dean for helping me out running the flags tonight. I really appreciate it, guys. Thank you so much. Let's go ahead and keep on going. We got about 10 problems left on here. So number 20, how would the graph of the function y equals negative 2x plus 4 be affected if the slope was changed to 2 and the y-intercept remained the same? So this y-intercept remains the same means that we're not going to change this plus 4. Now I'm going to sketch a graph because a picture is worth 1,000 words on these. I'm going to graph this particular equation in blue. So I'm going to go up to 1, 2, 3, 4 on my graph and plot my y-intercept. Sorry about that. Then I'm going to do my slope of, again, that's negative 2 over 1. So that's down to right 1, down to right 1. And so there is my line, rough sketch. Doesn't have to be perfect. What would happen if we changed that to a positive 2? So I'm going to change that to a positive 2. Well, my y-intercept stays the same, so it's still going to be right here. And now for a positive 2, I would rise 2 and run 1. Rise 2, run 1. So my graph would look like this, the pink line. So let's see what it says. The x-intercept remains the same. Now this is kind of tricky because it's asking about x-intercepts. Now remember, my x-intercept is down here where it crosses the x-axis. And so if you read that as the y-intercept, then you would be doing the problem wrong and you would select the wrong answer. So this one is not correct because the x-intercept does change. Okay, also looking down at D, I see that exact same thing, and so D is not going to be their answer. Okay, now it says the x-intercept becomes negative. Now remember, blue is our original. X-intercept is positive. It switched to negative, so that is good. So that works. And the new line intersects the original line. And we can see, yes, they do intersect right here at the y-intercept. And for C there, it says that it's parallel to, so that's not it. We're going to choose B as our correct answer. Number 21. The student graphed f of x equals x. So I'm going to do that in green. And g of x equals f of x minus 3. So if I was to substitute that in, that means that g of x would actually equal x minus 3 because I'm substituting this in for f of x. Which statement describes how the graphs are related? Okay, let's again draw this. I'm going to draw f of x equals x, and that, remember, y-intercept of 0, slope of 1. That is our linear parent function in green. Now, in my purple here, I'm going to graph g of x. Go ahead and write this. F of x. G of x is f of x minus 3, so I jump down to y-intercept of negative 3. Still have a slope of 1. That is g of x. So what has happened? The graph of f is shifted up 3 units to create the graph of g. So now in blue, I'm going to trace my stuff here. It says start at f and go up 3 units. Well, that's not right. The graph of f is steeper than, well, no, they're parallel, so they're not steeper. Graph of f is shifted down 3 units to get to g. That looks like it's right. Let's double check D just to be sure. The graph of f is less steep, and no, they're parallel. So our answer here is C. Okay, number 22. Linear function f of x equals x, again, that's our linear parent, is graphed on the coordinate plane. Let me go ahead and do that down here below. I'm going to do that one in green. And we're going to go ahead and call that f of x. The graph of a new line is formed by changing the slope of the original line to 3. Now, equals x. We got a new line. I'm going to call that one g of x equals. Now I have that x. So changing the slope of the line to 3 and the y-intercept to 4. So I got a plus 4 here on the end. Which statement is going to be true? The graph of the new line, I probably better graph that. I'm going to jump up to 1, 2, 3, 4. And the slope is 3, so rise 3, run 1. So rise 3, run 1 is going to look like this. So the graph of the new line is steeper. Okay, that works because my purple line is steeper than the green line. And the y-intercept has been translated down And I don't like that because it looks like I moved up. So that's not it. Graph of the new line is less steep. That's not going to work because of that less steep. No. Graph of the new line is steeper. Good. And the y-intercept has been translated up. Okay. Yes, that one looks good so far. Like that, up. And just check D just to be sure. The graph of the new line is less steep. And no, that's not going to work. So C is our answer. All right, 23. Graph shows the altitude of a hot air balloon after it leaves the ground. What is the meaning of the x-intercept and the meaning of the slope? So first off, I got to apologize. I didn't put any units on here. Let's see if it actually matters, though. The meaning of the x-intercept. Well, I looked down there, that x-intercept, and it looks like we're right here at the point 0, 0. Now, if this is the altitude of an air balloon as it leaves the ground, it would make sense that right here, time equals 0 is when the hot air balloon started. So that would mean that the hot air balloon, or the balloon, started, I guess 0 is at ground level. And again, you can describe that a bunch of different ways. As long as what you say makes sense, I'm going to check those manually, check those and make sure that anything that does make sense will get credit. Okay, meaning of the slope. So let's see, there's a point that it goes through. We go 5 this way and 1,000 this way. That's altitude. So our slope is going to be altitude divided by time. Well, I mean, I guess if there were labels here, not labels, like units here, that would be something like feet per second. So that looks to me like how fast the balloon rises. Okay, number 24. F and G are on the graph. I'm going to do F. Looks like F is a linear parent. G is a transformation of some kind. Which function best represents by the graph of G? Okay, so we're looking at G. Now, remember that's f of x equals x because it's slope of 1, y-intercept of 0. So it looks like the y-intercepts remained the same, so I'm not going to have a plus or minus on the end. So like this right here, that cannot be the correct answer, and this right here, that cannot be the correct answer. It also looks like G is steeper, and to get a steeper slope, I have to have a bigger slope, and when I look at my two slopes here, 1/2 and 2, a slope of 1/2 is actually going to compress my slope down. It's going to make it rise 1, run 2. It would make it shallower. So that's not going to be it. The slope of 2, multiplying values by 2, that's going to have a larger slope because it has a larger rise than it does a run. Number 25, graphs of linear functions are shown. Which function represented by the graph of G? Well, again, f is our linear parent function. They have, looks like the two are running parallel side by side, so they're going to have the same slope, which means I'm not going to have anything on the slope there. So that one can be crossed out, and this one can also be crossed out. Now, to get from F to G, it looks like I rose up, and it went up by 1, 2, 3, 4 units. So this one says +2, this one says +4. The +4 wins. Now 26 through the end are going to be reviewed from units 1 through 3. So let's go ahead and practice our slope here. Remember, our slope is going to be delta y over delta x, or change in y divided by change in x. So my change in y is how much I go from one to the next. So to get from -1 to -7, that is a -6. Delta x is over here. To get from 2 to 4, I add 2. So my slope, delta y over delta x, m equals -6 divided by 2, which simplifies down to -3 over 1. Is it a function? Remember, for functions, we're looking for repeated x values. And let's see, 2, 4, 6, 8, no repeats. So yes, this is a function. And then domain list of x values, put that little squiggle, and then just list your x values, 2, 4, 6, and 8. Then our range is list of y values. Again, put that little squiggly brace, and then list them -1, -7, -13. I guess I should probably write 7 as I say 7, and -19. Number 27, evaluate the following. F of 3. Now remember, all we're doing is we're substituting in, and we're taking f and we're plugging a 3 into where the x was. So f of 3 is going to be negative 3 times parentheses plus 4, and inside that 3 or that parentheses we are going to put the number 3 because that was what is right there. Now we just evaluate. -3 times 3 is -9 plus 4, which is -5. Okay, f of -2, exact same idea. That equals -3 parentheses plus 4. And in the parentheses, we are going to put this -2. Well, let's simplify that down. -3 times -2 is +6 plus 4, which is +10. Now we're going over to G. G is this equation here. So we've got 2 parentheses squared minus 6. And inside of that parentheses, I am going to place a 1. Well, now we're going to do our order of operations here. You do exponents first. 1 squared is 1. 2 times 1 is just 2 minus 6. 2 minus 6 is -4. Same idea on this one, 2 parentheses squared minus 6. Inside those parentheses, we are going to get a -3. Now let's be careful with this one as we do our parentheses and exponents first. Nothing to do inside the parentheses, but when we square it, -3 squared is -3 times -3, which equals +9. Don't take the bait there and put a -9 there. Now, 2 times 9 is 18 minus 6, and 18 minus 6 is 12. Now, for number 28, we're going to solve. Going to drop this guy straight down. Remember, for solve, we mean get x on one side and numbers on the other. Whenever I've got x's on both sides, I've got to decide which one is larger. The way we said that in the first unit was which one's Texas, and that is this guy right here. So, because it is larger, we're going to subtract our 4x on both sides. That is going to leave me with -5 is equal to 6x minus 4x is 2x plus 4. Now we're going to subtract 4 on both sides. That's going to leave me with a 2x on the right. -5 minus 4 is -9. Now let's divide both sides by 2. And then -9 over 2, that is -4.5 is equal to x. All right, number 29. This one's going to be a little bit more interesting. First question, do we have any distribution to do? We're going to distribute this -2 times x and times 4. So this 3x just gets written down. -2 times x is -2x. -2 times 4 is -8 equals 20. Be careful because you have to distribute the subtraction or the negative along with it. Okay, now we're going to combine our like terms. 3x minus 2x is just x. Minus 8 equals 20. Now we got to add 8 on both sides. That's going to leave me with x is equal to 28. So that's all we got for you for the review. Good luck, and I hope you guys used all your weekend time wisely, and you are ready to go on the test when you come in next week. You all have a great weekend.